Okay, just going to go through one last request from exercise 11E, which is question 6, which is asking you to integrate e to the 4x over e to the x minus 2 between ln 4 and ln 3. So it's a definite integration. And they tell you the answer is going to look like a over b plus c ln d, where a, b, c and d are integers to be found. Now, they give us a substitution. U squared is equal to e to the x subtract 2. And we've got an e to the x subtract 2, so that makes sense. We've got e to the 4x on the top, and the first thing I would consider is I'm going to think of that maybe at some point as e to the x to the power of 4. But might not need it, but that's one thing I can see initially. E to the x minus 2, because the substitution's just got e to the x's, I might need to use this as e to the x to the power of 4 rather than e to the 4x. Okay, don't normally get a substitution where either u or x are not the subject. So you've got two options. You can either not care and use implicit differentiation and just differentiate with respect to x, everything. And remember, implicit differentiation, we normally do it with x's and y's. So you'd effectively differentiate u squared like it was y squared, and that'd go to 2y dy by dx, or 2u, sorry, du by dx for this, is equal to e to the x goes to e to the x and minus 2 disappears. And if you make dx the subject, you get 2u over e to the x du. That's the quickest way to do it. You could do it other ways though, and if you just made u the subject, for example, so u is equal to square root everything, write it to the power of a half. So you can actually differentiate. Du by dx would be equal to, bring the power down, knock one off the power. But the chain rule says you've got to times by that bracket differentiated. Now what does that bracket differentiate to? E to the x. So this would be the same as, remember they prefer sort of square roots for this, so rewrite this as a square root now. So this would be e to the x over 2, actually not, I'm going to leave it as to the power of a half because it is easier to compare to the half there. Remember, e to the x minus 2 to the half is the same as u. So this is the same as du by dx e to the x over 2u. And if you make dx the subject, you get 2u over e to the x du, and that answer is the same as that answer, so they give exactly the same. Obviously the implicit differentiation is a lot shorter than all of this. Okay, back to the integral though. So this is equal to I is equal to, okay, I'm not going to change the limits yet. Okay, e to the 4x, again, I'm not going to touch that yet. It's not an easy substitution. Over e to the x minus 2 is an easy substitution, it's u squared, times dx gets replaced with this, 2u e to the x du. That simplifies. U divided by u squared, you lose a u. And e to the 4x divided by e to the x would go to e to the 3x. So this is the same as integrating between ln 3 and ln 4 to e to the 3x over u du. Right, and now this is where I might have to use that trick from the start, writing e to the 4x as e to the x to the power of 4. But yeah, so e to the x is, e to the 4x to e to the x to the power of 4, and then with this one, so let's do that. That'd be ln 3 ln 4 2 e to the x cubed over u du. And then from the initial substitution, which is there, if I made e to the x a subject, that's the same as u squared plus 2. So this would be the same as integrating between ln 3 and ln 4 two lots of u squared plus 2 to the power of 3 over u du. And believe it or not, this is easier. If we expand the brackets and simplify, we can integrate this. Just might take a couple of steps. So let's expand the brackets, so that would be u squared plus, actually u squared to the power of 3 plus 3 lots of u squared to the power of 2 times 2 plus 3 lots of u squared 2 to the power of 2 plus 2 to the power of 3 binomial expansion over u du equals between ln 3 and ln 4 two lots of u squared to the power of 3 is u to the 6 plus 6 u to the 4 plus 12 u squared plus 8 over u du. And now you could actually write these, expand the square brackets, but write these as separate terms all over u. So split them up into 4 separate fractions. That would be 2u to the power of 6 divided by u is 2u to the power of 5. 12u to the 4 divided by u would be 12u to the power of 3. 24u squared over u is 24u, and 2 times 8 is 16 over u is just 16 over u. Now that's going to be a logarithm, so I'm not going to write it in index form. Right, every term now can be integrated. So this first one, add 1 to the power, divide by the new power, so 2/6, or 1/3. Add 1 to the power, divide by the new power, so 12 over 4, or 3. Add 1 to the power, divide by the new power, 24 over 2, and this goes to 16 ln u. That is what it integrates. You don't need the plus c for this. Okay, now this is where you've got to make a decision. Looking at this, these are the limits x equals ln 3 and x equals ln 4. Can't make the substitution because I've got u's in there. So my option is, I guess, either replace all of these u's with something to do with x's from above, or change the limits so they're in terms of u. And for this one, I'm going to change the limits so we got u's instead of x's. So let's see how I can do that. So there's the formula for u there. So let's take the upper limit, which is x equals ln 4. If you substituted that into that formula, e to the ln 4 subtract 2 to the power of a half. E's and the ln's cancel, so that's just 4, subtract 2 is 2, so that's root 2. And then the lower limit is x equals ln 3. If you put that in, e to the ln 3 minus 2 to the power of a half. E's and the ln's cancel, so that's 3. Subtract 2 is 1, so that's 1. So that integral at the end there, that's exactly the same as if you did it between u is root 2 and u is equal to 1. So this is equal to 1/3 root 2 to the power of 6 plus 3 root 2's to the power of 4 plus 12 root 2 squareds plus 16 ln root 2's. Subtract 1/3 1 to the power of 6 plus 3 1 to the power of 4's plus 12 1 squareds plus 16 ln 1's. Squeezing that in. And looking at this, before I type anything in, my answer needs to be a fraction plus ln something. Let me check the answer. It needs to be a over b plus c ln d, where a, b, c and d are integers. So the first thing I'm going to do is just sort the ln out, which is, you should know that ln 1 is 0, so that disappears. So I've only got 16 ln root 2, so I can write that in, 16 ln root 2. And then I can just type the rest into my calculator. So we have 1/3 root 2 to the power of 6 plus 3 root 2's to the power of 4 plus 12 root 2's to the power of 2. And then we are subtracting all of this. So lots of powers of 1 to the power, so it's just quite easy, this one. So subtracting 1/3 plus 3 plus 12. So I reckon the fraction at the start is 70 over 3 plus 16 ln root 2. But again, that's an integer, that's an integer, that's an integer, that's not an integer. So how can you write that final thing as an integer? And the trick is thinking of that as 16 ln 2 to the half and use the log rule. Bring the power down. So this is the same as 70 over 3 plus 8 ln 2, and that would be my final answer. Everything's written as an integer. Let's check on the calculator. So integrate, first thing was e to the 4x, e to the x minus 2 between ln 3 and ln 4. Probably take a long time to work it out. Okay, 28 point something, and if I type in what we worked it out to be, which was 70 over 3 plus 8 ln 2, 28, so that's right. So yeah, it was not the easiest question ever, but options at the start on how you were going to differentiate. Implicit differentiation is the better option, it's the shorter one, although we did make use of u as the subject later on. Do all of the substitutions and end up with this, and recognize that if this can be integrated if you just expand and simplify, which is what we did there, and then did the integration. And then you had a choice. Either make it so it's a function in terms of x and use the x limits, or leave it as a function in terms of u and work out what the u limits would be, and then make sure your answer is what they wanted it to look like. And that was it.